Hello everybody and welcome to this video part 3. So let's continue with our questions. So the question 11 here, we have given the Earth's radius r and surface gravity g, the gravitational acceleration at altitude r above the Earth's surface is it g or g by 2 or g by 4 or 2 g's? As we have seen all together in the course, we have, let's denote a g prime, for instance, as a formula is a g m divided by the r square. The r is just like the distance between the center of a certain planet and the location where we are calculating this acceleration. That means from here to here is the global small r. So in our case here, what do we have? The Earth has the radius of r. It's just like from here to here. This is our r. And the new g that we are calculating is actually somewhere here with this distance. Let's denote just like this. Is another r. That means the double of the radius. So let's calculate the global g. We have g prime, we say it's g m divided by r square, with r is just like the r plus capital R. Let's make it as two capital r's. So the g prime would be what? The gm divided by 2 r's r square. This is given mathematically 1/4 gm divided by the r, with gm over r, it's a square here, would be equal a g. So the g prime, our global g prime, or g prime here over the g will give only 1/4. That means the ratio between the g on the surface and the g at a certain altitude of r is 1/4. So the correct one would be C. Moving to 12, what do we have here? A spring oscillator is in a simple harmonic vibration. When the displacement is half of the amplitude, the ratio of its kinetic energy, we are calculating kinetic energy here, to the total mechanical energy, that means the E total. So what's gonna be the ratio between these two? Is it 1/4, 1/2, 3/4, or 1/3? So for spring in the course period, we have seen that the E total is what? Is 1/2k the amplitude square. What is the potential energy? The U is 1/2k the displacement square. This is general, but this is the total displacement. And we all know that the E total is just like the sum of the kinetic energy plus the potential energy. So if we are looking for the kinetic energy, that's gonna be the total energy minus the potential one. The specific case here is what? The displacement is half of the amplitude. That means the x here would be a/2. This is our new x. So if we calculate the potential energy at this position, it's gonna be 1/2k a/2 squared. So here we have 1/2k, and this 2 beneath here would be 1/4, and it's gonna be the a square. What is this term? I did that in purpose just like to regroup all those terms in one place. So the u would be 1/4. This expression is already given above, it's the E total. Coming back to this expression, we are calculating what is the kinetic energy at the half amplitude displacement. It's gonna be the E total minus 1/4 E total. This is the potential energy. Mathematically, that will give what? This is 3/4 E total. Now, looking for the ratio, the kinetic energy over the total mechanical energy will be what? 3/4. So, they get back to the choices. We will for sure select the C. Okay, so here for 13 we have a mechanical wave propagating a medium. Which of the following statements is true? Medium particles migration with waves. Again, in the course we have seen all together that the wave in a mechanical or in a medium is responsible for transferring energy only, not the matter, not the particles. So the A is not the good choice here. The speed of a wave is the vibration speed of a particles. Pay attention here. This is very different speeds. So the particles are vibrating back and forth around a certain equilibrium position, but the speed of the wave is how this speed is moving along the medium. So the B is not the good one as well. Waves are a way of transferring energy. This is actually among the definition of a wave propagating in a certain medium. So the C is gonna be our answer. So for this question, it's just like we need to know what is the definition of a wave along a medium. The frequency of a wave is determined by the medium. The frequency is all the time determined by the source, not the medium. Finally, the C is the good choice here. Moving to the two final ones, we have 14. An object is in equilibrium under the action of three forces acting on the same point. F1, F2, and F3. This object is in equilibrium. Okay, so if one of the forces is removed, the object, what's gonna happen if we remove one of these three? Let's say F1 is removed. It must be an acceleration, uniform acceleration, straight line motion. That's gonna be the correct one. Actually, we're going to explain it later. For B, must be curved motion. That is not the good one. Maybe moving in a straight line at a constant speed. Okay, that is not the good one as well. Maybe in uniform curvilinear motion. Why we gonna choose the A? In first stage we had F1 here. If we make the vector sum of these three, the F1 would be like this, the F2 would be like this, let's say like this, and the F3 will be like this. So this is giving a closed triangle. That means we're getting back to the initial position. So for this, that makes it as F net would be equal to 0. And what we know as Newton's first law, F net is the ma. If the F net equals 0, that means the acceleration is equal to 0 as well. If we remove F1, we say we're going to get F2 and F3. The resultant or the net would be something like that. So as we see now, the F net is not equal to 0, which is M equal MA. I mean the F net equals the MA. If that is not 0, the A would be different from 0 as well. So the A would be a certain constant, which means the acceleration would be a uniform quantity, and the motion for sure would be in a straight line. Okay, so A is the good answer, or the one is correct for this question. Finally, for 15, we have when an object is vertically thrown up, we have an object that's gonna be thrown up here. Okay, upward, ignoring a resistance during the upward process of the object. What happens to the gravity as a work, and what's gonna be happening to the potential energy? So let's denote that. If you do remember, in the video part 2, we've talked about the question number 7. We said that the work is just like the force time the displacement. So when the object is moving upward, that means it's making some direction that in that case, I mean in that direction. But the gravity is downward. As we see, they have opposite directions, which means the angle between the two would be something like 180 degrees. That's leading us to conclude that the work, or the gravity, is doing a negative work. Okay, so upward and downward, the angle between the two is 180 degrees. That makes the work as a negative quantity here. So let's choose between B and D. Now let's get back to the potential energy. What is the gravitational potential energy? As a definition, we have mgh. Let's assume that the g is not changing, the m is not changing. What changes here is the h. That means the altitude from the ground to a certain height. The h is increasing. This is making directly the GPE to increase. So where the potential energy is increasing from, I mean between these two, we have potential energy increases, potential energy decreases. Finally, we can choose the B. Okay, so the gravity does negative work because the directions are opposite. The potential energy is increasing because we are increasing the altitude or the height of this object. This is all for this video part 3. Don't forget to subscribe and just like hit the bell, I mean, to get notified once the next video is posted. And you can for sure post your questions in the comments if you do have some.